Hey guys, Mrs. Diaz here. We are going to talk about law of sines and law of cosines. So these are some very important formulas you will need to know. We'll start off with law of sines. Law of sines is sine of A over little a equals sine of B over little b equals sine of C over little c. That is my law of sines. If it is calculator, you need to have your calculator in degrees. So I have my calculator here today and making sure, actually I'm going to check right now, make sure I'm in degrees. Okay, now for your final, it will be non-calculator. What that means is when we do law of sines or when we do law of cosines, it'll be unit circle values. So you need to know your unit circle. All right, let's do law of cosines. Law of cosines, it's a little different. It's a squared equals b squared plus c squared minus parentheses 2 times b times c times cosine of angle A. Okay, and there's 3 versions of this. If you know one version, you should be fine. But the next one would be b squared equals a squared plus c squared minus 2ac cosine b. And the last one, certainly not least, c squared equals a squared plus b squared minus 2ab times cosine of c. These are the law of cosines. Remember that law of cosines, the time we use law of cosines is sassy snake. So if we have side angle side, that's the sassy part, or if we have side side side, that's the snake. Sassy snake means use law of cosines. Anything else at all, use law of sines. Okay, so we're going to take a look at some examples. I'm going to show you how to set them up. We'll use the calculator to check our work, but remember, on the test, it'll be unit circle values, so we won't use the calculator. All right, let's look at some examples here below. Take a look at the first one. To find the distance across a small lake, a surveyor has taken the measurements shown. Find the distance across the lake. So it looks like we're given a side length here, we're given an angle, and another side length. Looks like it's side, angle, side, which is sassy law of cosines. Now, you want to label your triangle, and it definitely does not matter how you label it. I labeled it like this, ABC, which means across angle A is our little a, across angle C is our little c, across angle B is our little b. So it looks like we're trying to find little b. So the formula for the little b was b squared equals a squared plus c squared minus 2ac times cosine angle b. Now let's see what we have. Do we have our little a? Looks like that's 900, so 900 squared plus little c, 800 squared minus parentheses 2 times a was 900, c is 800, and then times cosine of angle b, which is 70 degrees. Now remember, this is all going to equal b squared, so after you take that value, take the square root, so you can get b. Alright, I'm going to use my calculator. I'm going to go ahead and plot this in. 900 squared plus 800 squared minus 2 times 900 times 800 times cosine of 70. Remember, your calculator must be in degrees. And I got this very large number. Let's see if you can see that. Yeah, very large. 957,490. But I need to take the square root of that. Square root this is my B value. Can y'all see that? 978. So the distance across the lake, B, equals 978.50, I'll just say 51. And this is in feet. Don't forget your units. There you go. Awesome. Okay, so that's how you do an example like number 1. That's a side angle side. Let's look at number 2. It says the distance between two cities is 50 kilometers. So these are the two cities, I'm guessing. 50 kilometers. Each city, so I don't think it's labeled. Let's label that 50 kilometers. Each city communicates with the satellite as shown in the picture. What is the angle of elevation the signal makes with the ground for each city? So they're trying to find the angle of elevation, meaning this angle, what angle creates with the city and the ground. So we're going to figure out that angle. And then they also want this angle because they're asking the angle of elevation for each city. So it looks like we have to find a couple angles here. Let's label our triangle. So I'm going to label it A, B, C. Again, doesn't matter where you put your A, B, or C. But it looks like we have side, side, side. So this is side, side, side. Or sassy snake. This is law of cosines once again. Now notice I want angle A and I want angle C. Let's start off with A. So I'm going to use A squared equals B squared plus C squared minus 2BC times cosine of A. A squared, that's 350 squared, equals B squared, that's 50 squared, plus C squared, that's 370 squared, minus 2 times B was 50 and C was 370, and times cosine of angle A. Angle A is what we're looking for. We actually don't know angle A, so we're going to solve for that. Now, you guys need to be very careful. I'm going to do this, show all my work. I'm going to do this in pieces. I'm going to do 50 squared, which I know that's 2,500, plus 370 squared. That's a large number, 136,900. 350 squared is 122,500. Goodness gracious. Minus, and then I'm going to keep all this in parentheses. 2 times 50, well, that's 100, times 370, well, that's 37. Did I do that right? Yeah. 1, 2, 3. And then cosine of angle A. So I multiplied these two, that's 100 times 370, that's where I got the 37,000. Now I want to combine these two numbers. It's like we're doing PEMDAS, okay? So I'm adding these together, 2,500 plus 136,900. That number is 139,400, so 139,400. This is minus this 37,000 cosine of A. This is where a lot of us make the mistake of subtracting these two. Don't do that because these are multiplying, so you can't subtract since they're not the same. They're not like terms. So I have this 122,500. I'm going to subtract this number from both sides. So subtract. Let's see what that gives us. 122,500 minus 139,400. And that's going to give us negative, I'm going to write over here, negative 16,900 equals negative 37,000 cosine of A. I know you can't see that, but the last step is divide, second to last step, divide both sides by that negative 37,000 because we got to get that cosine A by itself. So I got cosine A equals whatever this number is divided by negative 37,000. That gives me 0.456756. It's a very long decimal. Keep the long decimal because now to get A by itself, you have to do the inverse, cosine inverse of that 0.456. Second cosine of that long decimal, and there you have it. We're going to get angle A is equal to 62.82 degrees. So we got angle A. Basically, we would have to do the same process to find angle C, except instead of using this formula, I'm going to use the formula that has the C in it. Okay, but because of time, I want to actually look at a law of sines because these are really great examples, law of cosines. But let's go back to law of sines. So let me find a law of sines example by scrolling. This actually looks like an example for law of sines. Let's see. To determine how far a boat is from shore, two radar stations 500 feet apart, so these are 500 feet apart, determine the angle of the boat as shown. Determine the angles, out to the boat as shown, out to the boat. So here are the angles. Find the distance of the boat from the station A. So here's the boat, and here's station A. This is our unknown, and this is what we're trying to find. So we can use law of sines because notice this is angle, side, angle. Angle, side, angle. And that's not sassy snake. So because it's not sassy snake, we can use law of sines. So I'm going to label this triangle. I'm going to say A, B, and C. Across angle A is little a, across angle B, little b, across angle C, little c. So I'm going to do sine of, well, since I want the b, I want to do sine of 60 over b, sine of 60 over b equals, now I want to do sine of c over 500, since I have 500, then you might be thinking, well, we don't have angle C. Well, actually we do, because we have these two angles, and we know a full triangle is made up of 180 degrees. So I'm going to do 70 plus 60, which is 130, and then 180 minus 130 is 50 degrees. So sine of 50 over 500. Now, we're going to cross multiply. So it's 500 times sine of 60. Multiply these together equals b times sine of 50. And then to get b by itself, divide by sine of 50. And again, because we have a calculator, we can use the calculator. Remember that for the test, this will be unit circle. In fact, this up here is a unit circle value. 60 degrees is on the unit circle. Sine of 60 is root 3 over 2. So you would substitute root 3 over 2. I'm going to go ahead and just use the calculator. These cancel because of the sine of 50. So 500 sine of 60 divided by sine of 50. That gives us b equals 565.26, I rounded, feet. And there you have it. All right, so that's an example of law of sines. Continue practicing. Please reach me if you have any questions. And I'll talk to you guys soon. See ya.